All right, we're really getting down to the wire now. Last time we talked about sets, and we talked about sets for a reason. We're going to keep track of all the elements of our game. We have a whole bunch of different elements inside the game that we need to draw and update, but we also need to detect if they hit each other. So this is one of the final pieces that we need to make pretty interesting two-dimensional games. We need to be able to decide, did you hit something? So this lecture is going to focus on collisions. We're going to talk about how you manage detecting collisions among big groups of objects inside of your game. So with that, let's get started. Okay, let's think about collisions. For the purposes of our Rice Rocks game, we're going to assume that everything is a circle. So I've got one object here that's a circle, another object here that's a circle. They each have a center and a radius. Let's call that R1. Here's a center, and it has a radius. Let's call that R2. Right, so if I measure the distance between the two centers, let's call that D. And if D is greater than R1 plus R2, then I can be confident that these two circles have not collided, right? In contrast, if I have two circles like this, okay, where the distance here, D, is now less than R1 plus R2, the two circles overlap and therefore they have collided. Okay, so let's take a look at this in the context of our game. Okay, here we have the image info structure. And if you recall, we have a method called getCenter. That's getting us the center of the object. And getRadius. That's getting us the radius. So what we have is a circle with that center and that radius that bounds the actual image. So let's look at this. If I run it, okay, I have two objects here. I have my spaceship and my rock. Okay, and the spaceship, you can think of this as being the center, and here is the circle around it. Here's my rock with its center and the circle around it. And now to check if this rock and the spaceship have collided, I simply measure the distance between the centers and see if that distance is less than or greater than the sum of the radii. Now you'll notice there are parts of the spaceship that don't fill up that circle. So we're going to have a collision even when you're not quite touching the front left or front right portion of the spaceship. But that's not really going to affect the playability of the game. It'll be much easier to detect collisions this way, and you won't really notice while you're playing. Okay, so here's the sprite class that we've been building up. This sprite knows information about itself, like its position, its velocity, the radius, and so on. Right? It also has the ability to draw itself and the ability to update itself. I'm going to argue that this is a good place also to put the ability to detect collisions. Why? Well, the sprite already knows its position and radius. This is half of the information that we need. Okay? The other half is the position and radius of the other sprite. So I think that we should implement a method here. Let's call it collide. Okay, it takes itself. What else does it need? Well, I'm trying to decide if I collided with another sprite, so let's take another sprite as an argument. Okay? Now I'm not going to write this for you, but let's think about how we would use it. I would basically type something like sprite1.collide sprite2. And I want this to return true or false. I want it to return true if there was a collision, false otherwise. This allows us to act based on whether or not there was a collision. All right, so what information do I need? I'm not going to write this for you, but let's think about the information that I need. Well, I have self.pause and self.radius, as I said before. This is half of the information I need. I also need the radius and the position of the other sprite. So you need to think about implementing some additional methods like getPosition and other sprite.getRadius. Now, what can the other sprite be? The other sprite may be something of the same type. So if this sprite is a rock, you may be checking for collisions against other rocks. That's not really necessary in this game. Or you'd be checking against other types of sprites, like a missile. Okay, that is necessary. And you might also need to detect a collision with the ship. So anything that you might want to collide with has to have these methods getPosition and getRadius. With that, you can run the formulas that we talked about and return true or false based on whether or not you actually hit something. Okay, so this is how I might make this sprite class a little bit more useful to be able to detect collisions on its own. So let's think about what we have in our game. The main elements are the ship, the rocks, and the missiles. Okay, and there's one ship, there's a set of rocks, and a set of missiles. There's a reason we talked about sets. Rocks and missiles are a collection of items. You don't care about the order, and there are no duplicates, so sets become nice ways of keeping track of them. Okay, so with the ships and the rocks and the missiles, I have to think about collisions. All right, now what sort of collisions do I care about? Well, I care if the ship collides with a rock, and I care if a missile collides with a rock. If the ship collides with a rock, you die and lose a life. If a missile collides with a rock, the missile and rock explode and you get points. Okay. This is actually a little bit simpler because there's a single ship and you're checking against a set of rocks, where this is a set of missiles checking against a set of rocks. So how does this ship collide with a rock? I basically think about it by calling that rock.collide ship, right, that we just discussed. And this will return true if the ship has hit the rock. It will return false if the ship has not hit the rock, and you do the corresponding action based on that return value. Now, I'm not doing this just for one rock. I have a set of rocks, so I need to think about how to deal with that. So I recommend that you define some sort of function. Let's call it group collide, and that should take a group and a sprite. And don't use G and S, use better names. I'm just doing that because I'm writing here to save a little time. So what do? Right, I want to run through each member of the group. So for each member of the group, you have to check each sprite, let's call it SP in G. See, does SP collide with S? If the answer is yes, okay, then what are you going to do? You're going to remove SP from G, right? You're going to get it out of there because it's been hit. It was a rock. You know, in the simple case where I'm checking, you know, I'll pass in the rock set in G and the ship as S. If I hit a rock, I need to get rid of the rock out of the group. Then when I'm done, I need to return true or false, right? Because if I did hit a rock, then I need to know that. So I return true if you collide with anything in G, and false if S collides with nothing in G. That way, when you call this and you get the true value back, you know, hey, the ship has to blow up, I have to lose a life, and I have to do all the other logic to run the game. Okay? So this basic template here shows you how I might check if a single sprite, in this case the ship, hits any rock in the group of rocks. Okay? And this now is a useful building block to do that, and also to do your group collide. Now, when you're thinking about implementing your group collide function, I showed you in the last lecture a way of doing operations on sets. And I showed you that you could basically, I think I called it remove set. You start with an empty set and you iterate, you know, for S in my set. And you, if you want to remove it, you do rs.add S, and then in the end you do my set dot difference update rs. Okay, this is spelled out difference update. So if you do this, it will work. I want to just point out there's another way of doing this. Instead of actually having this set, the whole problem here was that you cannot modify a collection while you iterate over it with a for loop. We can solve that problem by saying for S in list my set. And if I want to remove something, I can now do my set dot remove S directly. Okay, why is this not a problem? Well, this here, when I call list of my set, it creates a new list. So it's effectively a copy of all the elements in my set. So you can iterate over them and then remove things from my set because you're not iterating over my set. Both of these sort of templates here and here will work for your group collide method. Okay, so we have one final piece to deal with. We've got this situation where we have to check for collisions between missiles and rocks. And in this case, missiles is a set and rocks is a set. So my group collide method is not sufficient. I'm going to have to build another function, and let's call it group collide, that takes two groups, group 1 and group 2. Again, use better names. I'm just using simple names here because I'm writing. So I have two groups. So imagine that this is the missiles, this is the rocks. Okay. Some of you are going to be tempted to write some very complicated logic in this group collide. Well, I want to tell you the following. Somewhere in here, there should be a call to your group collide function with some arguments. If you think about it this way and do it, this function is actually very simple. If instead you try to rewrite this from scratch, this becomes quite messy. All right? So use the code that you've already written, and I think that you'll have no trouble figuring out how to do the collisions among all the missiles and all the rocks, even though at first glance it looks like it's probably going to be pretty complicated. Okay, there's just a couple of more things that I want you to think about. Okay, the first is group collide. What did it return? Well, it returned true or false depending on whether or not there was a collision with any of the items in the group. Well, what do I need group collide to return? How are you going to use this? Well, you're going to have a set of missiles and a set of rocks, and you're going to want to know how many rocks did I destroy with my missiles, right? So you really want to return the number of collisions. All right? So you're going to need to keep track of how many times does group collide return true, count those, return that number. If the number is 6, you know 6 rocks were destroyed, you can update your score appropriately. Okay? In order for that to work, though, you're going to have to think carefully about what is G1 and G2, what order are you going to call group collide in, and which group are you going to pass off to group collide. Okay? But I want to caution you, don't try to rethink how you did group collide. If group collide works, just use it. Just try to use it appropriately from here, and this function, like I said, will be relatively simple, and your program will just check these collisions appropriately. At first, it may seem a little daunting to keep track of all the stuff that's going to be flying around in your Rice Rocks game. Okay, I'm going to have this ship and these missiles and these rocks, okay, but if you just step back and think about it methodically in the way that I've talked about in this video, you'll be all right. You have to start out by first thinking about collisions between two objects. Then think about a collision between one object and a set of objects. And then finally think about collisions between two sets of objects. If you build things up in this way and make sure each stage works before you move on to the next stage, you'll be all right. And when you're implementing one stage, make sure you use the results from the previous stage. Okay, so build it up one by one and use what you've just done. If you do that, you're going to be able to do this in a relatively straightforward way, and you are going to be able to build some pretty interesting games.